Hi, and welcome to another Feature Fridays. My name is Guy Bartram. I'm the Product Marketing Director for our Cloud Provider Business Unit. And today I'm delighted to be joined by Nicholas and Jorg. So Nicholas, let's start with you. You're new to Feature Fridays, so welcome. Do you want to give a brief introduction about yourself?
Yes, absolutely. Hi, everyone. Thanks for having me today. So I'm Nicolas Savides from NVIDIA. I look after the VMware partnership for the European region. So this goes across everything we do together, from our traditional VDI integration to all the new things we are doing these days around bringing AI to the VMware stack. So really collaborating across the region. I have a particular fondness for the cloud provider world in general. That's where I come from. I used to work for VH Cloud just before NVIDIA. So very happy to be there today.
Excellent. All right. Thank you, Nicholas. And Jorg?
Yeah, I'm a technical product manager in VMware's cloud provider team.
And everyone should know you by now. Okay, so great. Thanks a lot for joining. So today we've got Nicholas, we've got NVIDIA. We're obviously talking about Cloud Director with Jorg being on, and the new released NVIDIA GPU support that we have enabled in Cloud Director 10.3.2. So before we start diving into it, let's look at some of the kind of aspects of this that are interesting and different, and I think it's worth pointing them out. So I prepared a few slides, and Nicholas, perhaps, and Jorg, perhaps we just kind of talk through some of these as we go. So what we're offering here is Cloud Director with obviously NVIDIA GPU. And what I wanted to kind of point out was some of the kind of key differences to where people would normally, get GPU services from in hyperscaler clouds. I did a little bit of research, in AWS, in Azure, and in Google, you're not getting necessarily vGPU, you're getting GPU, and you're getting static t-shirt sizing, which comes with, a static amount of RAM, static amount of CPU, and a number of cores that you wish to use from the GPU. But some of the problems there I see, and some of those conversations online, are around the fact that actually, for different use cases, you might require literally no RAM at all because you're going to be doing everything on the GPU. And other use cases, you might require a significant amount of RAM and CPU. So it's not always going to be a perfect fit, those t-shirt sizes, and you often pay quite a lot for these. You can go for a longer term and get a longer commit and get a big discount, but obviously it's still a very large cost. And one of the other things to bear in mind is that the important things like operations per second, the amount of tensor T-flops you're going to have, and really the fact that this is kind of GPU rather than vGPU. Am I right in those kind of statements and assumptions, Nicholas?
Yes, absolutely. I mean, the level of integration we've made with VMware around or GPUs on the ability to virtualize is pretty unique, and it comes at almost no compromise. So yes, you could have t-shirt sizing like on the hyperscaler going pass through, but as a cloud provider, you probably want a bit more flexibility than that. So with the GPU, you can slice it and dice it the way you want. You're also keeping on the VMware platform all the compatibility with our spatial partitioning. So slicing physically or GPU with our multi-instance GPU and combining that with the GPU. So it's different, but that allows you, for example, as a cloud provider, to have a standard hardware with same GPU across machines, but then offer very different offering to your customer, slicing it in the way you want with the GPU or with spatial partitioning for guaranteed performance.
Yeah, and I think that's you're hitting on some of the key differentiators here. So our cloud providers are able to differentiate with this solution because it's VCD, it's using the underlying vSphere, NVIDIA support. So there is key differentiators like they can provide high performance networking and storage. That that's very optional depending on what their provider virtual data centers are configured to do. Critically, they can do kind of resource pooling and the allocation models. So that's where you're talking about the kind of slicing and dicing. So you could, if you wanted as a provider, offer t-shirt sizing, or you could offer flexible allocation. So it would then really suit the application much better than paying for CPU and RAM that you're not going to use.
That is actually something we will see that later in the demo when we set it up. The vGPU integration in VCD uses the existing concepts of resource pooling and resource sizing policies and placement policies, and you have a pretty good flexibility to combine these different things like the GPU policies and the sizing policies for the virtual machines. And that gives you as a provider the flexibility either to create different offerings on on your side, but it even allows you to publish these sizing policies to the tenants and let the tenants combine them in a self-service fashion, the GPU assignment that they need for virtual machines with the different sizing policies of the virtual machines if they want to. So it really gives you a huge flexibility to allow different business models to offer these services in VCD.
Really good point. Really good point, and that's, I think, one of the key differentiators. And one of the other key differentiators is obviously we're talking about GPU hardware and the ability to virtualize it, but there is then something called NVIDIA AI Enterprise, which is another very key differentiator, which is packaged with this solution. You can't run this solution without it. Nicholas, can you give us a brief overview? What is NVIDIA AI Enterprise? What's it all about, and what are the benefits to cloud providers?
Absolutely. So NVIDIA AI Enterprise is a jointly developed product that is really about bringing the NVIDIA AI compute data science expertise to the VMware stack. We've been collaborating for a decade on graphics with VMware, bringing GPUs to Horizon, etc. But today, most of our customers are using GPUs for compute workload, using their massive parallel processing capabilities. And we are not only providing hardware, but we are providing a large piece of software also at NVIDIA, optimized frameworks, developer tools, pre-trained models, etc. So AI Enterprise is bringing that to the VMware stack. So it's taking not only the vGPU drivers, but everything you need to run GPU accelerated application on top to prepare your data, to train your AI model, to do inference and run AI apps. So all of that come in a single package called AI Enterprise, optimized for vSphere, certified for vSphere actually. That's really an interesting opportunity for cloud providers that can now offer these capabilities onto their VMware cluster, managing it with VCD, offering the various possibilities, and going beyond, I would say, just IaaS or GPU as a service. You can still do that and there's still demand for that, but you can go one step further and say, let's do inference as a service, AI as a service, and go up the value chain for some of your customer to address new audiences. The data scientist won't care much about the IT. He wants just to run his code and benefit out of the box of GPU acceleration. That's what AI Enterprise for VMware does.
Yeah, and you mentioned a couple of really good things that I need to kind of zoom into here. This offering is not about the graphics side of it. It is about the sheer high performance compute requirements fulfilled by GPU for things like AI, machine learning, and inference model training, etc. So for our service providers watching this isn't addressing the graphics side of it. This is addressing the kind of the hard work, raw GPU power that are required for, like you say, data science and things like that, and these new enterprise applications that are differentiating customers and growing in demand rapidly. And actually, there was a recent survey done by VMware, and about 40% of enterprises are actually looking for GPU services now, and that's an incredible uplift in the last couple of years. We're really starting to see this ramp up now, and it's a great time for cloud providers to start looking at this. The other thing you mentioned is AI Enterprise. So reality is that's going to, in this service we're defining now, is that's going to present the service provider with an application catalog of applications that are certified and tuned by NVIDIA to the to whatever they're kind of supporting, whether it's AI or ML or inference learning, whatever it might be. So they come, and as you say, data scientists don't want to know about the infrastructure. They'll just grab an instance of TensorFlow or whatever it might be, that supported version from that catalog, and then they can use that. And this does allow for, and I've just put this other slide up, we've got the infrastructure flexibility that Jorg's mentioned. We've got then this broad possibility of services going way beyond the infrastructure level into the AI as a service, into kind of mixed services as well. And all of that from the service perspective, from the application service perspective that NVIDIA delivers, is supported. So this is going beyond our kind of cloud marketplace, Bitnami applications, to stuff that is really tuned for the services that you're looking to deliver. And I think one of the things we're discussing at the moment is actually, our service providers don't want another application catalog. So, can we sync that with App Launchpad and pull those applications in? And of course, App Launchpad is extensible to provide other services, and we will be hopefully in the next few weeks bring up some methodologies on how that can be done and achieved.
Yeah, in general, this follows the methodology that we have for VCD to really offer the service provider huge flexibility on where they draw the line between what they offer as a service, as a managed service to their tenants, and what the tenant can do in a self-service fashion. While we saw on the last slide with the hyperscalers, they offer pretty much just the infrastructure, not even very flexible. And as a tenant, you have to do pretty much all within the operating system and within the libraries on your own. While here, the service provider can decide if they just want to offer virtual machines with vGPUs in there and let it be that way, and give the tenant the flexibility for the rest. But they can also go up the stack and offer some more managed services, including these NVIDIA Enterprise AI features, and building perhaps even templates for certain services and adding that to App Launchpad and to the service catalog. So they really can go up the stack and provide some machine learning as a service offering.
Yeah, and you're right. Sorry.
So go ahead, Guy.
I was just going to say the managed service part is key, and what we're seeing a lot of now is service providers actually partnering with AI ML specialists and delivering those services on the platform.
No, and I think that's where the opportunity lies. On Guy, you were giving some numbers around number of customers looking for GPU resources, etc. The interesting thing we see at NVIDIA is that if you look at how many companies are looking at AI or GPU accelerated application, you're anywhere between 70 and 100% within the next year. When you look at how many successfully deployed AI application, that number goes down dramatically, because at least half of the AI projects fail. And one of the main reasons is not because it doesn't work, or not even because they don't have the right data scientist and AI practitioner. It's about operations. It's about running AI application at scale, making it replicable, monitoring it, on basically all the challenges that goes with going into production. So, and that's what our partnership with VMware and AI Enterprise is about, and that's where we also need infrastructure specialists like cloud provider. It's really about how do you take all the AI frameworks that are available on the market, pre-trained model on tests that companies have done at small scale, but make it operational, put SLA on it, and make sure it runs 24/7, because these are now business critical apps. And that needs somebody who knows how to operate IT. That needs somebody who provide an easy and familiar stack to deploy, manage, monitor applications. And that requires also familiar models, frameworks, etc., that we provide, that are optimized, that we provide at NVIDIA. So that's where we have a unique story, cloud provider on VMware and NVIDIA.
Yeah, totally agree. And just to kind of look at the business model then, so there is some baseline requirements here, right? You've got to have NVIDIA AI Enterprise validated hardware underneath and GPU hardware, which the provider has to purchase from NVIDIA directly.
No, actually, yeah.
Oh.
So the hardware actually, so our NVIDIA certified server are servers coming from almost every OEM on the planet. So just pick the one you prefer. You're working with Dell, with HP, with Lenovo, or Supermicro. You will have a choice of servers to choose from that have the NVIDIA GPUs and that are compatible with the VMware list. So we are not selling the servers directly. It's really coming from your favorite OEM.
Yeah, absolutely. There's a huge OEM route for you guys to market. Okay, sorry, yeah, misled people there. Obviously, then you've got to install the hardware, set up the clusters, and get everything working in vSphere. And there's a vSphere minimum requirement as well, isn't there, Nicholas?
Absolutely. To support NVIDIA AI Enterprise and VCD deployment, you need vSphere 7 Update 2 at a minimum to be able to run the software.
Yeah. Okay. So, could a service provider nicely sort of segment a cluster off just for this purpose with VCD?
Mm-hmm. Yeah, so we will see later in the demo. The cards are obviously installed to particular servers, and there are some restrictions for the virtual machines that are consuming vGPUs. For example, currently there is no vMotion available for them yet. So DRS, the distributed resource scheduler in vSphere, takes already care of that and just will exclude the virtual machines from the automatic rebalancing. So you can actually mix hardware or servers with and without vGPUs in the same cluster, and everything will work. Nothing will break because of VMs trying to be deployed without on a server that doesn't have the vGPU. However, there are some implications in the configurations of the virtual machines that might make it absolutely more useful to create separate cluster just for vGPU workloads.
Yeah, that's what I'm thinking. I think it might be certainly easier if there's demands on the vSphere version and things like that. It would probably make sense to segment that as providers are updating different clusters.
Since we are talking about that topic, there's also a different aspect to that. Since we cannot vMotion virtual machines with GPU configured, you also cannot place the ESXi host in maintenance mode automatically without any interruption of the virtual machines running there. And that's completely different than from your regular virtual machines where you just evacuate a server where you need to do some maintenance, install some upgrades, do some hardware replacements, whatever. And since you evacuate the server with vMotion, there is no interruption to the virtual machine availability. And that's not the case here. So in this case, you really have to schedule some maintenance windows with your customers that are using these virtual machines with the vGPUs in there. And that, of course, makes it it's easier to handle if you have a smaller set of virtual machines running on these clusters and don't have something where you are not used to need this maintenance windows, and then you have some where you need this maintenance windows. So it's much cleaner and likely much easier to structure your business and your operations around if you have separate clusters. But it's technically not really necessary.
Yeah, that's a great point. Yeah, must bear that in mind for operations. And of course, then you've got the NVIDIA AI Enterprise, and that delivers, am I right, Nicholas? It delivers monthly updates to the applications, but only the quarterly ones are supported. Is that right?
So two things. So all the applications, so supposing from PyTorch, TensorFlow you mentioned, or Triton Inference Server, for example, all of that are updated on a regular basis. Yes, usually monthly from our NVIDIA GPU Cloud catalog. So it's downloaded either automatically or at your own rhythm. You can even create a local repository as a cloud provider if you want to operate in a disconnected way. Yeah. So all of that is upgraded on a regular basis. Yes, our support goes only back a few versions. So we highly recommend you upgrade them regularly. But it's not only for support reason, which is obviously important, but also for performance reason. Each version comes also with improvement, new features, etc., that will be delivered automatically for your end users.
Right. Okay. And I don't know much about the upgrade procedures of these applications. I'm guessing there's downtime involved with that, or?
Yeah, there might be. It varies a bit on the framework itself, but yes, in most cases, it's a container, so it's pretty light. But yes, that's well, depending on your architecture, you might have downtime, or you might have partial downtime, let's say. So moving workload to the containers that are not already upgraded yet, while you upgrade some of them. So yes, but the good thing is that it's all handled automatically, so there's very little intervention to be made from the cloud provider himself.
So here's a good question. I think it's a good question. It might be a challenging question. We might not know the answer to this at the moment, but I see on the website that vSphere and NVIDIA AI Enterprise are supported with Tanzu. Does that support follow through into Cloud Director delivering Tanzu-based clusters, Jörg?
Yeah, that is something. Again, it depends on which Tanzu configuration you use. For TKGS with the vSphere provided Tanzu, VCD consumes these resources from vSphere automatically without any need to install container service extension or whatever. And in this case, VCD just does not care what functionality comes to the individual nodes. So you can use that from a vSphere level, but VCD has no influence in the placement or the selection of the Kubernetes nodes. So VCD is completely independent from that. It does not break. So it works. It complements the functionality in vSphere, but it does not care about it and does not have to care about it. On the other hand, if you use TKGM, then your container Kubernetes worker nodes are virtual machines, and in this case, you would have to combine the CSE templates with the vGPU profiles, which is something that is technically possible, but it is some effort because you have to massage the container service extension to work and select the right policies.
Yes, and to complete that, so today AI Enterprise support is really with TKGS, so that's where so TKGM, I guess, will be coming, or full support will be coming when let's say the two branches merge in the future in your Tanzu catalog. So today its support is really with TKGS. And yes, I was mentioning all the applications that we are bringing with AI Enterprise are containerized. So we work with vSphere, we can deploy in a VM, and we come with an open source Docker in that case. Yes, if you have Tanzu, definitely use that. As part of NVIDIA AI Enterprise, we have also our GPU operator, so ready to integrate into Kubernetes and manage the GPU with the Kubernetes layer. So on vSphere, it's good. On Tanzu, it's great. So taking all the benefits of the Tanzu platform to manage your GPU accelerated application is an even better choice. One slight note: Tanzu support requirement is vSphere 7 update 3C, so slightly even higher version than the update 2 requirement for vSphere, but there are definitely some benefits in terms of application management here.
Yeah, I think that's a session actually I'd like to run next time, Nicholas, is actually to look at AI Enterprise and what it can do, because that's something I've not seen, and having another operational tool in play here offers more managed service potential, and certainly that sounds like it's got a lot of capability.
Of course, today we are focusing on the integration with VCD, but there's always that alternative business model that you have as a service provider to create some dedicated private cloud offering and dedicated clusters where you don't have to care about any shared environment or multi-tenancy, and it follows pretty good along together with that concept of a managed service, where you have some dedicated resources for a tenant and you work closely with them, perhaps even providing some business knowledge and AI skills to help the tenant with building their AI applications.
Yeah, absolutely. Yeah, I think there's that single tenant kind of private cloud instance where you can stand up that TKGS and be very happy operating and playing with your own operational tools in that environment. What we're going to dive into now, Jorg, if we can get the demo views up, is VCD driving multi-tenancy vGPU as a service, which is, like we've discussed, a different kind of view on it. It will drive higher margins, we hope, for our cloud providers, provide a lot more flexibility for customers, and with AI Enterprise, provide that catalog of applications for them to deliver to their customers.
Yeah, so let's see how you configure the vGPU support in vSphere, and then, of course, mainly in Cloud Director. So here we have the view of a vSphere client in vCenter, just to confirm that all the steps are done in vSphere to configure the NVIDIA card. So if I select individual server, an ESXi host, in the configuration tab on the main window, you have the graphics section, and there you can see your NVIDIA card or NVIDIA cards that are installed in that server. The most important information here, actually, for our case, is the memory that provides that's installed on the card, because that's like the defines your granularity and the amount of resources that you can, how much you can share this card to different virtual machines. That's a requirement that you have to do upfront before you can use the cards, obviously. And that goes along following the installation guide for the cards. You have to install some VIPs on the ESXi host with the proper drivers, and make sure to set up the policies properly in the profiles, policies in vCenter for these vGPUs. Now, these vGPU profiles that are configured in vCenter then will show up in the provider portal. So here we are in Cloud Director, in the provider portal, in the infrastructure resources. You might have to rescan the vSphere cluster if you want to do that, like in a running environment. And then there is a new section in 10.3.2 with the vGPU profiles. And these vGPU profiles are the ones that are really derived from vCenter. And these vGPU profiles you set up in vCenter, and they actually define how large or small the resources these virtual graphic cards are that get mapped into the virtual machines. So all that configuration with the GPU profiles and the sizing for the vGPUs themselves happens in vSphere according to the administration guide of vSphere and the NVIDIA cards there. And Cloud Director, as so often, just consumes the policies that are configured in vSphere. So there is no additional configuration from that end when it comes to carving out the different resources for from a single physical card in vSphere. That's something you do in vSphere and not in Cloud Director. Now, what you can do in Cloud Director is to edit the GPU profiles to give them some information that is visible. We will see that later in the tenant portal. So usually the profile names in vSphere are likely somewhat technical and include like the size of the card with the 10C, 20C. It's like how many gigabytes of memory.
If you read it, so grid is for vGPU, A100 is the name of the card, 10 is the amount of memory you allocate to that specific profile. On C, it's because it's a compute profile. But yes, you know that when you're from NVIDIA, your end customer might not know.
Exactly. And as a service provider, you might not want to show that, or not need to show that to the end customer, because that will be part of your service offering. So you can rename or give some alias label for the profile in the tenant facing name. And we also introduced like a free text field that will show up with the when the tenant creates a virtual machine and maps that vGPU into this virtual machine, the profile into the virtual machine. So here you can link to some guidance, either from NVIDIA or directly from your homepage as a service provider or from your documentation, how to use the GPU inside the guest operating system. Because again, VCD just cares about providing the virtual machine, but it does not care about what happens inside the guest operating system or inside the application. And here you can optionally point the tenant to some additional steps that might be needed inside the guest operating system, to install some drivers there, to how to set up proper framework, stuff like that. And that happens here on the vGPU profile. And when you select one, you then can see these the settings that you typed in here with the tenant-facing name and the instructions. There is also a usage metric section there that allows you to see which virtual machines from which tenants are consuming this CPU profile. So that is something available here in the UI. At the end, we will also see that's also available through the API, and that's a way how you can meter the consumption of your GPUs and then break that down on a per tenant base. Because right now we don't yet have an integration with the tenant app with chargeback. So that's something you have to keep in mind as well.
Yeah, Jörg, and just a quick question. So the instructions that you're providing here are around, it could be around configuration in the guest OS. Is that something a service provider could pre-do in terms of builds available for the customer to use?
So that is something we will see again, since it acts GPU profile when it comes to mapping that to the virtual machine. It acts as a placement profile and works in the same way as a placement profile. And these placement profiles can be used with templates in the VCD catalog. So you absolutely can create, as a service provider, ready-to-use templates that not only include the placement policy or with the vGPU profile policy that tells VCD, well, always run that virtual machine that gets deployed from the template with the vGPU in there. But as a service provider, of course, you also can install operating system and prepare all the frameworks or whatever application you want to install inside the guest operating system with the template.
Okay, great. So it's additional value add they can provide there.
Yeah, absolutely.
Okay.
Yeah, in the provider VDC view, we are still in the provider portal in VCD. When you have a bunch of provider VDC, you notice if the provider VDCs own or are backed by clusters in vSphere that have vGPU profiles. You see that small NVIDIA icon in the provider VDC view. And yeah, for these provider VDCs, you then can use them to back your organization VDCs and create the policies. We can also dig deeper into the resource pool section of a provider VDC, because these resource pools in vSphere are actually where the resources come from for the provider VDC. And you can see here, again, you now see the different resource pools that are existing on clusters where you might or might not have vGPUs installed. And you see them again with the small NVIDIA icon. As you can see here, it's absolutely possible to mix clusters with and without, or resource pool backed by clusters with and without the graphic cards in there in the same provider VDC. But again, it might make sense to separate them out based on the different restrictions that we have.
Yeah.
And then for the actual cloud resources, you can create vGPU policies. That's still in the provider portal. Now in the cloud resources, we have a new policies section for vGPU policies, and they work pretty much in the same way as VM sizing policies and placement policies. So you define a generic description of the vGPU policy, and then you map these, or you publish these policies to the different organization VDCs. And by publishing it to the organization VDCs, that's when you flip that switch and enable the service for a particular tenant. And the tenant then working in the tenant portal in this organization VDC, they can consume these policies and when they create new virtual machines or deploy VMs from templates. In the same way as you would do that with the sizing policies for t-shirt size offerings, or the placement policies that generically map the placement to VM groups in vSphere. Now let's walk through the creation of such a vGPU policies. Of course, you can create quite a lot of them. They are just abstract constructs, and map then as you want to your different tenants and offer different, sort of levels of sizes, whatever, to the different tenants. Now, to create a new vGPU policy, you give it a name and a description to identify it, and then you select the vGPU profile that we've seen in the infrastructure sources list. And here's an important thing that depends on, again, which of the vGPU series you have based on the name, that's letter at the end of the name, and the size, how much memory you have in there. You can actually allow, and that's what the count column is in here, you can define how many of these virtual GPUs should be able to be assigned to a virtual machine. Be aware that there is no over-provisioning when it comes to the memory, so you really have to do the calculations and make sure that the whatever's physically in the card you carve out as a maximum for the particular profile. Yeah, then you get to the provider VDC scope. So here you get a list of all the different provider VDCs that you want to use this policy in. You can optionally, so this setting is optionally. If you click to the no button on the radio button, then it just works everywhere, and it's published everywhere. But you can also limit the scope down and just offer that on particular clusters, and that's where it comes handy if you just have a separate cluster or provider VDC just for these vGPU use cases. And you can even dig deeper into that and go down to the individual cluster and select or enable or disable the policy, the profile just be used for this particular cluster. So that again impacts the placement of the virtual machine that uses these vGPUs.
Yeah.
And for the placement, again, you can even narrow that down even further. So not only to the particular cluster, but even down to VM groups in vSphere. So it's like a placement policy in vSphere where you restrict certain VMs to run only on particular on the cluster. We do that, for example, in general for licensing perspective, or if you have some different hardware and different performance of CPUs, whatever, in the same cluster, and you can narrow that down here for the vGPUs as well. Again, this is optional. You can select the no button here, and then it will just ignore the VM groups that are configured in vSphere.
Yeah, I think it definitely makes sense to have, that PVDC cut off and separated, and then you've got this just because it contains everything, makes it a lot easier.
And if you again think about the restrictions regarding vMotion and maintenance mode for the host, you can use these settings to really spread out certain workloads, certain policies for different of your tenants to different VM groups and have more control over that, or make sure that they even the same tenant uses, I don't know, that all the VMs from the same tenant land on the same group of hosts to make it simpler to schedule the maintenance windows, things like that. So it's very flexible, but again, it's optional. If you don't want to, or if you don't need that granularity, just select no in these previous screens, and then the policy will be used in whatever provided VDC technically works and has the cards in there. In the next step, you can optionally, again, define a sizing policy or combine a sizing policy with that vGPU policy. That, again, is optional. You don't have to do that. That's what we discussed at the beginning, that you can map the VM t-shirt sizings to the vGPU profile if you want to offer that all in one bundle, very easy to consume from the tenant. If you select no, then the tenant can use the vGPU profile and combine it on their own with the sizing profiles or the sizing settings for the virtual machines. If you, one thing that you have to keep in mind, and that's a very important one for CPU, it doesn't really matter. So you get your regular sizing policy options here for the CPU. For memory, that's different because that's a requirement for from vSphere and NVIDIA that all the virtual machines that have vGPUs configured always have to have 100% of memory reserved. So you got a 100% reservation for memory for this virtual machine that has configured the vGPU. And that is an important aspect because, first of all, that limits, of course, the amount of overcommitment. Literally for vGPU VMs, you cannot do any memory overcommitment on the same host. It also, since we are talking about vCPP, it also impacts the way, well, usage meter works or usage meter counts with these virtual machines. So they act different than perhaps your other virtual machines. Again, here the reservation guarantee is like hard-coded because it doesn't make sense to have anything lower. If you do not select the to combine the sizing policy here, you still should make sure, of course, that virtual machines that use this vGPU policies have by the sizing policies for the same org VDC, whatever, and the org VDC section configuration that you can guarantee these memory reservations. Otherwise, the virtual machines just will not power on.
Yeah, it's a really good point. So yeah, I didn't think about that. So from a usage meter standpoint, we normally default to 50% billable vGigabyte RAM if there's no reservation applied. So here you're going to be getting 100% of the point value. Yeah.
Yeah. So keep that in mind, and that also again from an like a capacity planning aspect. Just be aware that virtual machines with these GPU are like cannot be overcommitted or are fully reserved when it comes to memory. So it might make sense again according to your allocation model and then according to your business strategy or business model to even put them into different org VDCs for the tenants, just to have the flexibility and keep them separate from the other workloads. You still, of course, can do the cross VDC networking and so on to not lose any functionality when it comes to network connection, but yeah, make it easier to handle and do the capacity planning for these.
Yeah.
Yeah, another very nice feature that we had for the placement and sizing policies for a long time, but API only. Now here it's important and also got into the UI. For the policy, you can define that whatever virtual machine uses this policy gets some additional configuration in the advanced configuration in vSphere, like the key value pairs that get into the VMX file. And that is something that you typically use for these virtual machines to define the video size. Because by default, I think it's 4 megabyte video RAM for a virtual machine, which for a vGPU does not make sense in most cases. So that's where you define this other special parameter that gets placed during deployment into the VM config. And then, yeah, you can add whatever additional settings you might have want to have here. That
so
functionality.
This will be, sorry to interrupt you, this will be readable via vSphere, this is not something that's stored in VCD.
Exactly,
metadata.
That gets directly applied into the VM config in vSphere.
Okay, cool.
So it's not metadata in VCD, but it's really a
key value pairs.
Yeah, a key value pair that you have in your VMX file and the advanced configuration in vSphere.
Cool.
Yeah, and then we get a summary and we create the policy, and then the policy will show up in the vGPU policies list. Now, the next step as a provider is, well, to publish these policies into the organization VDC. So here we have the organization VDC view. We are still in the provider portal of Cloud Director. And now you again can see for the ones that already have vGPU policies published, you see the NVIDIA icon in the list. And the in the org VDC setting, we have a new policies where we had all the Kubernetes placement, sizing, storage policies, and so on. There's the new one now with the vGPU. And that's where you just add the vGPU policy from the list of policies in your Cloud Resources tab, select the one and publish that to the organization VDC. It follows the same methodology as for sizing placement policies or Kubernetes policies. So nothing special in here. Yeah, and that's pretty much what you have to do from a provider perspective. Now let's switch over to the tenant portal. So now I'm switching my hat and I'm a consumer. I'm a customer of the service provider using VCD in the tenant portal. So I'm logged in to the tenant portal, open up my organization VDC that has the vGPU profile published by the tenant. And I get my vApps virtual machines configuration whatever. And if I now deploy a new virtual machine with the new VM button, there's the new compute type selection that we have here, where you can select the vGPU enabled one. General purpose is just your old one with without vGPU, and then vGPU enabled allows to select the vGPU profile. And when you select the enabled one, you get the list of all the published size vGPU profiles for that organization VDC, and then you select that one. And then now you can see with the profile, that's the tenant-facing name, not the technical name in vSphere, but that's the label that we created in the very first step, and the instructions in here. And then, again, it depends on the setting in the profile. If you added the sizing policy, yes or no, that depends on how this wizard looks like on the lower side. If you have to select the sizing policy on your own, if it's not included in the vGPU profile, or if it is already in there, then just the sizing policy section disappears because there's no need to select that. So that's for you as a provider to define, do I want to give my tenants t-shirt sized, easy to consume, just hit the GPU button and you get whatever I configured for you. Or if I want to give them the flexibility, and then they have to define the sizing policies and the size of the virtual machine. Yeah, once the virtual machine is created, you can see in the compute section of the VM details, there's the vGPU section in there that again has the profile, the number of vGPUs, if you have multiple ones, and the instructions. Yeah, and from there, once the virtual machine gets powered on and deployed, the VM gets the vGPU assigned, and that's now a view from the vSphere client for that virtual machine that get created. Of course, that's nothing that the tenant has ever access to, but as a service provider, I just want to show that you get the full reservation in the for the VM memory of 100% automatically. And you can see in the PCI devices that you get the NVIDIA vGPU grid configured in there. Now, once the VMs are deployed, that's now again, nothing special in here. That's just how the concept of VCD work with the catalog. Either as a tenant user or as a service provider want to prepare it, perhaps you install the drivers inside the guest operating system. Perhaps you install frameworks. Perhaps you even install some demo applications or whatever you want. And then you capture that into the catalog. So you can create a VM template from that virtual machine. Be aware that the virtual machine has to be powered off for that. So that's one restriction compared to other virtual machines where we can save the memory state as well as part of the catalog item, or the templates. Doesn't really make sense for these vGPU workloads anyway. So they have to be powered off. And then you clone them as a VM template into the catalog. And then it follows the same, again, compute policy strategy so that you have can tag the template with the placement or sizing policies, and define if they should be modifiable or not. And then, yeah, depending on the settings here, it's guaranteed that whenever a user deploys a new virtual machine from that template, it automatically gets the vGPU configured because it all automatically gets the placement or vGPU policy assigned to that.
So just a quick question, I guess to Nicholas, really. So at this stage, when you're creating the image to be published to the catalog, as a service provider, you could then create that VM with the policy, then go into AI Enterprise, find the right application that you wanted for this particular workload, deploy that into the VM, and then shut it down and start your packaging process.
Yes, that's exactly it. At that stage, it's really picking into the NVIDIA GPU Cloud catalog and pick the right application. So is it for data science? You'll pick Rapid. Is it an inference server to run a pre-trained model? You'll download Triton inference server. Is it for training? You'll take PyTorch, for example. So yes, that's exactly it. So you have the VMs, you have the vGPU loaded. Now just pick your application from our catalog. Can be even a third party that we don't necessarily provide, but of course we highly recommend to take the supported one. an optimized one, but that's really the next step. And then yes, well, just start working on it.
So just thinking, like, okay, so I can create a base image. Let's say I've got TensorFlow deployed. I don't know what version it is. Let's make up version number, version 10, and I start Q1 with a nice image with TensorFlow on version 10. Q2 comes and there's version 11, but there's also some drops in between in TensorFlow. What I should be doing really as a provider is perhaps quarterly updating all my images for all of the last major versions, and then putting instructions in this this policy or the catalog to update from ALP or the enterprise catalog the application to the latest version as and when needed.
Yes, and I would say both are possible. So it's you can you can, well, obviously each time you create a VM, you can download the latest version. If it's running, you can run script to force the upgrade on a regular basis. It can be a maintenance window, or it can be pre-scheduled. Same thing, if you want to have a template preloaded, that's possible too. And then we recommend, yes, you redefine your template once a month if you want to avoid some download time at each creation, for example.
Yeah, yeah. Okay.
Okay. Yeah, in the last screen, here we see, depending on, again, the setting in the catalog, when you create as a user a new VApp from the template, then it automatically gets the vGPU applied. Yeah, that's pretty much it for the workflow. So it's actually super simple to consume from a tenant user. That's, again, on purpose. We want to make it as easy as possible, of course, for the tenants to consume these additional services. For the service provider, as a reference, again, we don't have any integration with tenant app yet for chargeback of that. However, we can do some metering of the usage for the vGPUs. So in the UI, in the infrastructure resources in the provider portal, you can see for each of the profiles which virtual machines and which from which tenant in which org VDC are consuming these vGPU profiles. And that information also is available through the API. So in the Cloud API, REST API of VCD, there's some endpoint, a new one with the vGPU profiles that gives you the consumption response in JSON format. Alternatively, there's also, of course, since the vGPU profile is part of the placement policy or works in the same way as a placement policy, we have audit events that are tagged or categorized with the placement policy and linked to a placement policy ID. So you can also do some event-based tracking and track whenever a virtual machine powers on that has a vGPU placement policy configured, and then sort of start counting or tag that as for your metering purpose.
Or you could use the key value pairs from vSphere, couldn't you?
It could be for vSphere,
yeah.
Or of course, if you work with templates, create metadata for the templates, and then get that into the tenant app. But that's something you have to do automatically, and it's based on all the virtual machine metadata then.
And for this report, we're just getting the fact that it was powered on. We're not getting the actual time it was up for, or are we?
Well, you get the powered off as well.
Again. Okay, then you can work out the time. Okay, good.
But then that again depends on your business model. We'll see in the current version, there are some other restrictions that have some impacts there. So don't only rely on just these information here, but put them into context. So currently, in this implementation in VCD and vSphere, first of all, VCD has no knowledge about the actual consumption of vGPU profiles in vSphere. So there is no support for quota yet. That's something that we work on. And there is no way for VCD to know how many of these vGPU profiles in vSphere are actually consumed, because we don't have the APIs yet in vSphere for that. So it always can happen that if the profiles are already fully used, that a virtual machine from a tenant does not power on. VCD has no impact on controlling that, not like for the CPU and memory resources, where VCD can ask and like proactively make sure that there are enough resources in vSphere. And there's also no way for VCD to reserve capacity on the vGPU for a particular tenant, which again works for CPU and memory reservation, where you have like the allocation model, and you can carve out if you want some hard pieces of the cake for each tenant. With the vGPUs, we don't have that functionality yet. So again, it can happen absolutely depending on your allocation with the provider VDCs and the org VDCs on top of that. If you do sharing between different tenants that VMs from a particular tenant does not power on because another tenant is already consuming all the vGPU resources.
Yeah,
and
so I think that kind of points towards a preference for a managed service initially.
Mm-hmm.
Yeah,
because that helps you to have an additional like management or business layer on top of that. Or alternatively, of course, you can do some finer grained organization with the group policy placement that we've seen, or provider VDC allocation. So that allows you to get more into some dedicated resources per tenant, so that you at least have a per tenant allocation of the vGPU resources. But of course, that sort of limits your sharing in between tenants and limits the economy of scale. So that's sort of the balance as a service providers you always have to consider when you think about your shared resources in a multi-tenant context.
And you mentioned, you know, for this version of it, I mean, this is the first version of the GPU support that we've actually put out there. So there's I guess a good development roadmap to kind of bring in a lot of more capability to ensure the self-service.
The points that I mentioned, for example, that as a provider, you can give quotas for tenants based on the consumption, so that the tenant know, okay, I only can power on like 3 virtual VMs with vGPUs in there. That helps or will help with the over allocation.
Yeah. And
then eventually, we are of course working closely with the vSphere and the NVIDIA teams to get these APIs and metrics in vSphere to create reservations and reporting of the used capacity of these vGPU resources in vSphere as well, so that VCD has more knowledge about that, and then can use that information to impact like the allocation models, and can use that as part of allocation models as well for the org VDCs.
Sounds like it's heading in the right direction then. Fantastic. Okay, any final thoughts, chaps? I mean, for me, this is, I think, a brilliant opportunity for cloud providers. It's going to be a bit of a learning curve, perhaps, for a lot of cloud providers. And, you know, we've covered some of the intricacies here. It may be better to start with a managed service and see how things go, get used to it for a few customers before opening this up more. And hopefully, as we build more capability and opening up as a real as-a-service, self-service offering.
But again, you have seen it's not rocket science.
Yeah.
Rocket science already is part of the hardware, the libraries in there. But the configuration in VCD follows pretty much the same strategy, or the same workload that we had for placement policies and sizing policies as well. So there's nothing really surprising in there.
Yes, and I think that's exactly it. It's remove the rocket science out of it. It's, I said, most customers start to do AI, needs the compute capabilities. They have a hard time knowing where to start between operating the hardware, operating the vGPU, the compatibility, etc. This is an absolutely great opportunity to capture all these new workloads that are coming into enterprises, and really think how build on what you have. So your VMware cluster, your VCD environment, and just that one GPU option. As a managed services, could be as infrastructure as a service, but that's definitely just probably not where you have the most value. But think managed services, think training as a service, inference as a service, and these kind of things. This is really where you will solve tons of problems for the end users, and I think we are making it as simple as can be.
Brilliant. Yeah, leave the data scientists to the science to the data scientists, and just do the easy bit in VCD. Love it. Guys, thank you very much for your time today. Nicholas, thank you for joining us. It's been a pleasure to have you. And Jörg, thank you as usual for walking us through and prepping those screenshots. I know we borrowed the engineering lab there to get access to that. So thank you very much for doing that and taking the time.
Thanks.
Take care, everyone. Cheers.
Thank you.